In the previous lecture, you were asked to think about these video log questions. So hopefully you spent a little time answering these questions. And now let's go ahead and discuss them. So you were asked, what is mathematics? Well, the dictionary meaning of mathematics says the study of numbers and their form, arrangement, and associated relationships using rigorously defined literal, numerical, and operational symbols. Mathematics is observing the world around you, characterizing things or objects in different groups, components based on certain attributes, problem solving, and generalizing structures and patterns. What is the problem was the next question you were asked. Because why are we working on this? Because in a math class, you know you just solve problems, right? So what is a problem? A question raised for inquiry, consideration, or solution, or proposition in mathematics or physics stating something to be done. Or my favorite, an intricate, unsettled question, a source of perplexity, distress, or vexation, or difficulty in understanding or accepting. So as you can see in a math course, you're mostly solving problems, then it's natural to expect some or even a lot of discomfort depending on your previous preparation. If you could solve all problems in this book or in this lecture series, then your mastery level would put you in the next course ready to deal with more sophisticated and abstract problems, and you wouldn't really be listening to these lectures, would you? So it's important to remember what problem solving really means. Well, what do you think is a mistake? Well, the dictionary meaning means to blunder in the choice of, or to misunderstand the meaning or intention of, to identify wrongly, confuse with another. Making mistakes while doing mathematics is often related to misunderstanding the meaning of the symbols or rules or misapplying these to the problem at hand. Students always think that they have to be able to do the problems right from the beginning flawlessly because they see their teachers do problems on the board almost always flawlessly and without much energy. And the same is expected from themselves. This is absurd because the teacher has spent years studying this field and doing these problems over and over again with a lot of dedicated practice and study of the fundamentals. That's why they're at the level they're at. It's like observing an Olympic athlete and us wanting to perform at that same level instantly. That's not going to happen. So learning mathematics, you are going to make mistakes, and that is how you're going to eventually become proficient at the subject. Well, how long do you think a student waits before they say, I don't know, after reading a problem and getting help? Well, about 30 seconds. So you can put a timer and see how long 30 seconds is, and then decide for yourself how long you would wait before saying, I don't know how to do a problem after reading the problem. Well, I can tell you what I think. On average, a person should wait how long before getting help in this particular intermediate and developmental algebra level. It depends, of course, on the problem and the complexity of the problem, but on average, I would say wait at least 10 or 15 minutes before you raise your hand and say, I don't know, or give up and go somewhere to get help. It allows your brain to process, to figure out what to use, what not to use. When you do this kind of struggle on your own, you are more likely to retain what you have learned. So take steps on trying to aid yourself to get out of a situation or a problem you are trying to solve. I will give you some steps on problem solving very soon. So when you say, I don't know, you're diffusing responsibility to someone else for making you understand. But making sure that you understand why you wrote what you wrote and not just say, I don't know, especially if you're the one who wrote something on a problem, because we want you to think about why you wrote what you wrote, what is your logic or intuition making you write what you wrote, and then figuring out what was wrong and what mathematical principles will allow you to fix the mistake. This will build a bridge from where you are at to where you should be at. By saying I don't know and somebody else showing you how to do it is not going to do that necessarily. So don't just expect an answer from your teacher or someone else on what your mistake was and what the correct solution is, but figure it out yourself, what the mistake was, and fix it so that you will retain the material longer. Experience the freedom in mathematical thinking. We don't want you to become robots, and a rote memorization of the steps in solving a problem is not going to take you very far. Problem-solving strategies. There is lots of creativity in solving problems. There's not just one way of doing something. Many different ways can lead to the same solution. As long as you can justify every mathematical step, you can use it. George Polya in 1945 described basic framework on how you can approach solving problems. Understanding the problem is very, very important. Making sure you've copied it down correctly from the book to your notes is important. Read the problems and extract information from it that you think is relevant. And sometimes that might mean breaking the problem into smaller, simple problems to work on. Devising a plan. To devise a plan to solve a problem, make a list on the For My Eyes column of all the things that you think are relevant, and then one by one start applying them until you find the right one. To do this, you have to observe connections to similar problems from the previous lectures that you may have attempted and previous homework. Observing the patterns and solutions and applying them to new solutions. That's the problem-solving skill that most employers and other majors require when they're applying mathematics. Investigate why, how, when some patterns emerge, because that will pay you dividends later when you're doing more complex problems. If you feel completely stuck, close your eyes, empty your mind out, and blurt out anything that comes to your mind regarding the problem. Most often, you'd have blurted out what to do, and that usually is the right answer too. I have tried this technique in my classes, and it is amazing. 99% of the time, students who have said, I don't know how to do a problem, ends up solving the whole problem, and everybody else is just amazed because they just heard the student say, I don't know. Third step is to carry out the plan. And then fourth one is to review and make sure you've actually answered what was asked of you, and also whether you can extend the ideas. So keep these strategies in mind to solve problems. We're going to end the lecture with the homework for Module 1, but for right now I just want you to remember mathematics is about playing with objects just for fun, replacing components with other objects to see what happens. This can lead to interesting structures and objects that eventually can be used in real life. There's a lot of creativity and art involved in doing mathematics, and this is what is going to really train you when you're in other fields that require mathematics. We want you to take about 15-20 minutes to do this. Use the online stopwatch because we really want you to spend some time on it. Your assignment for video log 1.1 is to take a handful, like 25 to 50 toothpicks. You could use nails, pins, paper clips, just a whole bunch of objects of the same type. Come up with a method to express or communicate to someone else how many of these objects you have. So if you're working with toothpicks, how many toothpicks have you got without using our base 10 number system or our decimal system? In other words, you cannot say I have 35 toothpicks. We want you to come up with a new method. That might mean you have to come up with your own symbols, what they mean. For example, you can use tally marks, you can use letters. Use something that is not base 10 number system to identify how many toothpicks you've gotten. Once you're done with that, then answer the following questions. Describe the system you have developed. Could you generalize your system if we gave you more toothpicks or remove some of your toothpicks? What difficulties did you encounter in doing this exercise? So remember, it's very important that you do not give up. Break it into smaller problems. Go look around, talk to friends, but it's important you come up with something. And then would someone else be able to understand your system? So once you've developed a system, try explaining it to a friend or somebody else and see if you can explain to them how you would develop counting system. For answers, you will have answers in Module 1, Lecture 1, but we want you to really spend time on this before you attempt to hear that lecture. All right, so just relax, give your brain a chance to show what it can do. Things that look difficult at one time can seem easy at a later date once you understand the material. For example, if you look back and saw what you did in kindergarten or first grade, you might think, oh, that was easy. But when you were actually in kindergarten or first grade, perhaps you did not think it was that easy. So don't let the past dictate your ability in the present. Start fresh and have a positive attitude.